Okay, we need to finish up lesson 5.2. We're going to first talk about the factor theorem. This theorem is going to help us with example problem 3. So it says the expression x minus a is a factor of a polynomial if and only if the value a is a zero of the related polynomial function. Alright, so what does this mean? It means that if we have a solution, x equals 2, and we have another solution, x equals negative 3, x minus 2 would be a factor, and x plus 3 would also be a factor of that polynomial. Alright, so these would be the solutions, and because those are the solutions, if you would know then that those would have to be factors. Okay, so what you notice here is what you're doing is basically getting everything on the same side of x. So you're subtracting 2 from both sides there. You're adding 3 to both sides. Okay. Alright, so what is a cubic polynomial function in standard form with zeros negative 2, 2, and 3? Alright, so our factors are x, and then just take the opposite of that, so it's going to be plus 2. And then x minus 2. So you're just taking the opposite sign. That's a positive 2, so it becomes a negative. And then we have a positive 3, so we'll have x minus 3. And we'll set it equal to 0. Alright, so we're working backwards here. Before what we were doing is we were given the polynomial and we had to find the zeros. Now we're given the zeros and we have to find what the polynomial is. Okay, so now what we have to do is we have to multiply those two factors together, and we're going to do it by foiling. So first times first, x times x is going to give us x squared. X times negative 2 is a negative 2x. 2 times x is a positive 2x. And then positive 2 and a negative 2 is a negative 4. And then we have to multiply that by x minus 3 equaling 0. Before we multiply by x minus 3, let's combine like terms. So we have x squared. A negative 2x and a positive 2x cancel, so we have x squared minus 4. And we're going to multiply by x minus 3. Okay? Alright, so now we have to FOIL again. So we have x squared times x. That's going to give us x cubed. The outers, so x squared times a negative 3x gives us a negative 3x squared. The inners, negative 4 times x gives us a negative 4x. And then a negative 4 times a negative 3 is a positive 12, equaling 0. And so here, is our resulting polynomial. And again, we came up with that just by knowing what the 3 zeros were. Okay, part B. What is a quartic polynomial function in standard form with the zeros negative 2, negative 2, 2, and 3? Alright, so let's take the zeros and write the factors. So our first 0 is negative 2, so that means we have to have a factor of x. So the opposite of negative 2 is positive 2. Alright, a negative 2 again, so we're going to have x plus 2. A positive 2, the opposite of that is negative 2, so we're going to have x minus 2. And then we have a positive 3, so x minus 3. is a factor. Okay. So let's FOIL these first two together. So x times x is going to give us x squared. X times x. And then the outers, so we have x times 2 is a positive 2x. And then the inners, 2 times x is a positive 2x. And then last, 2 times 2, positive 4. Alright, so that becomes x squared plus 4x plus 4. And then we have to multiply by x minus 2 and x minus 3 still. Okay, now let's multiply those two together. We can't FOIL because they're not two binomials, so we're going to have to distribute. So we're going to have to do, we have to multiply x by all three of those terms. So when we do that, x times x gives us x cubed. X times 4x is a positive 4x squared. X times 4, positive 4x. And then the negative 2 times 4 times 4x, and then x squared. So negative 2 times x squared is a negative 2x squared. A negative 2 times 4x is a negative 8x. And a negative 2 times 4 is a negative 8. Alright, so that becomes x cubed. Then we have a 4x squared and a negative 2x squared, so it's going to be a positive 2x squared. A positive 4x and a negative 8x, so it's going to be a negative 4x minus 8. And then we have to multiply this by x minus 3. And we'll be done. Alright, so distribute the x. So x times x cubed, x to the 4th, x times 2x squared, positive 2x to the 3rd, x times negative 4x, negative 4x squared, and then x times negative 8 is a negative 8x. Okay. Now distribute the negative 3. So negative 3 times x cubed is a negative 3x cubed. Negative 3 times 2x squared is a negative 6x squared. A negative 3 times negative 4, negative 4x is a positive 12x. And a negative 3 and a negative 8 is a positive 24. Alright, so what are we left with? Our final polynomial is going to be x to the 4th. Okay, so that's gone. We have a 2x cubed and a negative 3x cubed. So that's going to give us a negative x cubed. We have a negative 4x squared and a negative 6x squared. It's going to be a negative 10x squared. We have a negative 8x and a positive 12x, so it's going to be 4x. And then plus 24. Equals 0. So this, ladies and gentlemen, after a lot of work, is the polynomial that's derived from those zeros. Okay, we're going to skip problem 4. We don't have to worry about that. We're going to go to problem 5, where you're going to be identifying a relative maximum and minimum using graphing calculator. Now, since we're not at school, I don't know if all of you guys have graphing calculators, so we're going to be using Desmos. So I want you to go to www.desmos.com. So let's plug that in right now. Okay, so you should be on this page. We're going to click on graphing calculator. Okay, so it's going to take you here, and now you're just going to type in the polynomial. So it's f of x equals x, and then to get the exponent, you hit the little caret key. So let me so it would be x, you would hit that key, and then that'll get the cursor up in the exponent. Alright, so x to the third, oops, then you're going to have to hit the right arrow, plus 3x caret 2, hit the right arrow, minus 24x. Okay, and you can we're going to have to zoom out a little bit to get the full picture. Alright, so there you have it, and then you can use your finger if you have a touch screen. Okay, so what you'll see here is the relative minimum and the relative maximum are the peaks of these humps here. So like this point right there, notice that if you imagine a mountain, okay, and you're standing on top of it, you're standing at the highest point. Well, this is going to be the relative max. Okay, there's no point higher than that in that area. Okay, this point, okay, you know, it's down at the bottom. That's the lowest point you're gonna be at. So that's going to be a relative minimum. So we got to find what this point and this point are. So we're going to go over, and you're just going to literally click on the point, and it tells you, I don't know if you can see the screen, negative 4, 0. Okay. Now the relative maximum is going to be the y coordinate of that. So the relative max is equal to 80. and then the relative min is equal to, X out of there, the ordered pair is 2, -28, so the relative minimum would be -28. So -28 and 80. Alright, so let's go back to our problem. Okay, so our relative maximum, it occurred at the ordered pair -4, 80. So we're going to include the x coordinate, but we're going to do it in a way, this is what we're going to say. We're going to say the relative there is a relative maximum of 80. So 80 is the relative maximum at x equaling -4. And then the relative minimum was at 2, -28. So we'll say there is a relative minimum of -20 at x equaling 2. Alright. Okay, so this wraps up 5.2. In the first example, just to recap, problem number 3, we worked backwards. We were given the zeros and then we came up with what the polynomial was. And then here in problem 5, we identified relative minimums and maximums. Alright, so I hope you learned something, and we'll be able to answer questions in class. Thanks.